Morning, everyone. Well, thank you, Linda, for your introduction, and thank you, Joe, for the invitation to this important workshop in the very critical transition period. So I'd like to switch the gear a little bit, actually back to our core talk, our traditional data, survey data integration. So my focus of this talk is to give you a flavor about how much effort we had to put to get that integrated data to meet the need for our use. Then now actually we are thinking about expanding the data source more than survey or admin data or some other data outside of government. Just brief outline. Well, data harmonization. I think there are many. Again, this one, depending how you look at that, the different ways to define that. I think ultimately this one is to get the combined data, useful for our needs. So then the procedures actually that the work needs to be done. And specifically, I'd like to give an example. The project I have been working on for many years for National Science Foundation, my national NSF colleagues here, and just give a brief thought. So as I said, data harmonization, ultimately to get the one unified file based on multiple sources, the coherent, in a way that you can do analysis, also produce data product and the analysis. So, well, this is not the whole list of why actually we do that, why we do combine or harmonize the data. Certainly, it enhances the data utility. You actually have to deal with some discrepancy or the comparability issue, and also related to this workshop addresses some quality issues. And then it can certainly increase the estimation capacity, the data the usability, and granularity, as John mentioned in the morning, micro or macro level estimation. And then that directly or indirectly responding to current data collection atmosphere, climate. So we can reduce or minimize avoid the redundancy. We can directly collect from our respondents. Then hopefully we can cut the cost a bit. And then the other thing is, I think data harmonization, particularly industry or even U.S., the government sector, state, they have a kind of similar goals, and they may collect similar data here and there. And if we want to do some kind of comparative analysis, then you need to do some harmonization for variables and other things so that we can compare, we can make the apple-to-apple comparison. The challenges, the issues you have to deal with that, the data, the nature of data, disparate data, data linkage issues. We just heard at the presentation this morning. And then particularly the data items, the measures, depending on the source of data in different way. Survey questions, they intended to collect that, that measures, but admin data or transactional data, I think, for different purpose. So that also needs to be addressed through data harmonization. And as I mentioned, that ideally that allow us to get the data actually we want with the less expensive manner, but it may not be necessarily always the case. So need to do some sort of cost-benefit analysis. When you combine that, again, kind of different kind of the population or whether or not how that data represents, and then you're going to actually deal with the different types of missing data and some bias issue. So I think a challenge, again, back to this, the overarching goal for this workshop, data quality measures. And that quality measures so far, there's no universal data quality measures for right region, unlike the traditional data collection. But it's got the fitness for use. Okay, as I said, I thought it might be helpful for us to think about this whole harmonization issue. For the, again, our ultimate goal is to produce national statistics, official statistics with that quality. So I think the end goal is basically the same, whether we do a single-based data collection or combining. So this example is to my knowledge, one of the really well-planned, established data integration, the program for the federal statistics. That is scientists and engineers statistical data system maintained and sponsored by National Science Foundation. So if you are familiar with this system, the structure got changed a little, but for the purpose of, for the sake of illustration, I like to stick to this format. The system, the format, early 1990 to 2008, that the NSF maintained that structure, basically based on 3 different surveys: National Survey of Recent College Graduates, Survey of Doctorate Recipients, and National Survey of College Graduates. So each individual survey, standalone survey, it has its own data product, and also their own the report and then the measures, indicators. And then after that, these 3 surveys combined so that the integrated data system can produce science, the nationally representative indicator of science and engineers, the workforce in the nation. So as I said, the 3 surveys, largely kind of take the different parts of the population. NSRCG covers recent college graduates with a bachelor's and master's degree in science and engineering field. SDR covers U.S. earned PhDs. And then NSCG, basically everybody else. Again, as I said, this system, this kind of structure lasted until 2008, before American Community Survey took over the decennial census long form. So before that, the national sampling frame only available once a decade. So NSCG get the base sample, and then over time, that the supplemental sample came from NSRCG and SDR to get the nationally representative. The sample for this is very important, the population. So you can see that why actually there's the motivation for integrating 3 different surveys. So the benefits to harmonizing multiple survey data, I think that's related to this program, but I think we can also generalize to other situations. By combining, it can certainly broaden the coverage of the sample in cross-sectional way, in this case, nationally representative sample. The other thing is it's not kind of physically combine the data, but this is repeated survey biannually. Then if you have the survey over time, then you can do that time series analysis or trend analysis. But again, here, the data harmonization, variable harmonization there. You need to make sure that the variables measures over time consistent. Sometimes for the right region, you change that kind of wording that to make sure that those things are the same, so they address some discrepancy through harmonization. And then the other thing, over time, if we link that data at the record level, then it can also give a longitudinal component to that. So you can do, in this case, the career track of the individuals, of the individual scientists or engineers over time, how their job career, job track changes. Okay, so now actually you kind of see the context. So three independent surveys, standalone, well-designed, and now we try to combine these three survey data to produce one integrated data for that the purpose. So again, this is the well-planned and designed the program. So there's several areas that the coordination and standardization and the guidance and that kind of things actually happen. So before even data collection, each survey, the program, there's the coordination about the survey questions. In this case, they know, that the certain questions will be asked for each survey so that when you combine, they can do the analysis. Data harmonizing in other situations, we don't usually actually have that kind of luxury. But I think it is important to have the measures we want to use to harmonize across different surveys. The other thing is also variable naming conventions is simple but very important. So this, again, the plan in advance. So each survey contractor, different questionnaire numbers or things like that, but they use the same variable name so that when they deliver the file, then that the variables can be used for that integrated file. And the variable formats. What kind of if there's category, then what kind of categories for even the age categories or race, ethnicity, or other categories provide the kind of the standardization so that survey contractors follow that variable format. So when you combine that, you can use those variables in the same category. And then, as I said, the few variables over time that the question wording changes, then to make sure that over time that the estimates, the trend analysis is not affected by that the question wording change. And also that the sample design and data collection protocols, sample design in this case, to make sure that to the extent possible, coordinating two or three different survey programs, whether the same person is selected more than one survey, then try to avoid asking the same questions, the multiple questions from the multiple survey programs. And then, in this case, 1990 to 2008, initially Caddy, and then the early 2000, the web mode was introduced. And then NSF tried very hard to have the all survey contractors adopted this web mode so that there's minimize that the mode effect across the different surveys. So that's again the planned integration program. But we don't usually actually have in the future. We actually have to think about how actually we can address these kind of things when we actually have to combine the data after the fact. But the other thing is also that guidelines, one of the key measures that occupation and also occupation, their education history. And key variables there are what institutions. They got the degree, their degree level, and then the field of degrees. The more than several hundred nowadays, more than 100 different degree fields, occupations, so many different occupations, and then also those things are evolving, keep evolving. So this is one of the key area NSF wanted to make sure that all three the survey programs have a kind of the same standardized coding scheme. So that's, again, the very the intensive endeavor. And also the editing, consistency or that, the range edit. But then if we look at relatively complicated the survey equations, then there's the multiple items, yes, no, and then, they ask them, they respond to more than one items. So there's a certain editing rules you may actually want to impose, but the possibility is more than one. So in that sense, also the NSF provides guidelines so that in certain situations, subject decision should play in then what kind of editing rules they should apply, so that at the end when you combine that all data, the quality, at least in this, consistency across the surveys. I mean, the response rate, same thing. I mean, the response rate, but in this case, each survey has a survey disposition code. And based on that, a very detailed survey disposition code. Based on that, you classify whether respondents and non-respondents. If that's non-respondents, then whether that their eligibility for this survey is known, or still we don't have enough information to declare that their eligibility status. So that again, to certain situations, could be subjective. So there's another guideline, so that they can comply to that guideline. So the response rate can be compared across the surveys. Also, when you combine that, you have that, because that also affects your weighting. Okay, so not just for the data processing or preparation, the later the moving to the coordination effort, moving to the more statistical data process, particularly imputation and weighting. So these surveys have almost close to 200 the items, and all items missing values are imputed. And then the imputation method mainly based on hot-tag imputation. So that the method-wise, pretty, the surveys use the same method. But if you are familiar with the hot-tag imputation, that depends on your auxiliary variables, the variables in your imputation set. What variables determine most nearest the donor? That many times each survey contractor use their own subject matter experience and knowledge, and using the frame variables, other variables. That makes sense. But yet, notice that later there's some variation across the survey programs in terms of identifying that input variables, candidate variables, and then from that one determine what variables we should use for the hot-tag. So with that one, the NSF started to develop and distribute the guideline, mainly actually based on identify all data source for imputation and the later actually weighting. What kind of data sources are available for each survey? The frame, and then if that's the kind of longitudinal survey, then the past survey data. So put all those variables, and then the recommend that, hey, this is the variables that related for each item we think you should consider. And then again, the other thing is, that the variables mostly subjective, and then but then try to bring more model-based variable selection. In this case, the regression approach, logistic regression or other linear model, so that from that the many number of input variables, you cannot afford to use all those variables, but somewhat instead try to avoid the predominantly subjective fashion in determining the variables to the model-based, so that actually at the end, this combination of the statistical modeling process also your subject matter. The weighting procedure is the same thing, identifying the input variables. For a long time, they used to use a weighting cell method, but then again, as you expand more variables, so then in order to deal with that many variables, the response propensity model was introduced. Then response propensity model, again, then there's many different ways in survey setting, whether or not you should use weight, whether or not actually you should use individual propensity score value or weighting cells or things like that. Those are things the NSA put the effort to do the research and then provide the recommendations so that survey contractors follow or use that guideline for their best decision. But the other thing is the variance estimation method. So again, before that, each individual survey has their own variance estimation method, whether Taylor series or replication method. But now later, knowing that these three survey data are combined, then what should be the method for that combined, the variance estimation method for the combined data set? And the replication method, that's a choice. Then actually in turn that it provides some guidance to survey contractors to create a replicate weight in a way that later those replicated combined as a part of the that integrated data system. So then, a lot of coordination and guidance and that the standardization. Then once you actually combine that, in this case, I think that Ben kind of mentioned that the three different surveys, there's overlap. In this case, the population defined by mostly degree. So if we have somebody actually has multiple degrees, in my case, I got the bachelor's and master's degree from foreign country, and then came here to got the PhD. Then I could have been selected for SPR. I'm eligible for SPR, which is a survey of doctorate recipients, but also I'm eligible for NSCG, and the part of that decennial census long form sample. So it is important to identify that the cases who could have been selected more than one survey, identify overlap cases, and then address those overlap cases through multiplicity adjustment. So then after that, we can produce a weight for integrating data for cross-sectional wise. And if we combine the data over time, then also for the longitudinal analysis, need to create the weight. And the variance estimation method, I just actually mentioned that, but make sure that the right variance estimation method is documented and available to users. So that through this harmonization or integration, we get the new data product. The new data product, the microdata, can be used for the analysis as if it's kind of the single survey-based data. And then, as usual, need to provide the metadata, methodology reports, and also, mentioned that microdata. So, as I said, this example really kind of shows that integration of multiple survey data for the federal state really actually requires a major resource endeavor in time and the budget and staff. So then actually think about that. When we move to or try to utilize a different source of data instead of after the fact, hey, what kind of data available, and for that one, how actually we can combine. I think it really actually needs a plan in advance. It all actually, again, kind of same way for the survey program. As a survey program, what kind of the measures in the case we want to produce through the survey, then with that one, Are there any existing survey programs or data available? And then with that, understand how those are measured and what kind of the plan actually we need to have. So ideally, all those things can be after that repeated, like the survey program. Survey, you design in the data collection and the processing and disseminate. Same thing goes to this combining different sources of data, and then once you establish a harmonization process, then the harmonization process can be repeated for that specific program. But I think this is going to be, as you all actually recognize, that no small task, not to mention that the quality measure issues. Okay.
Thank you, Don. I especially like the acknowledgement that it's going to take resources. Something that's an increasing concern. So, Wendy, do I need to do anything? Okay. No, I just thank you for being here. I was having trouble changing slides with two people in the room. I was, talking about Missouri.
Oh gosh, well we'll see. Okay, so I think I gave it to you, Scott, but I think I have to unmute everybody.